When you picture evolution, what's the first thing that comes to mind? For most of us, it's that iconic tree of life, right? Everything branching out from one single root. But what if that's not the whole story? What if there's another way to look at all the evidence? Some scientists are suggesting a totally different model, and we're going to dive into it. So on one side, you've got the classic tree of life. This says that every single living thing, from the tiniest bacteria to you and me, all traces back to one universal common ancestor. But on the other side, there's this idea of a forest of life. Now, the idea here is that life didn't start from one single trunk, but from many separate, distinct starting points, almost like a forest full of individual trees or bushes. Each one could change and adapt, for sure, but only within its own basic blueprint. So the big question is, which idea does the hard evidence really point to? And that's really the heart of the matter, isn't it? When you have these two massive competing ideas, how do you even begin to weigh the evidence? We need some kind of reliable filter, a way to sort the solid, high-confidence science from the stuff that's maybe more of an educated guess. Well, this is where biomedical engineer Dr. Rob Stadler comes in. He developed a framework for doing just that, and he got the idea from his work with medical devices, a field where the standards for evidence are, incredibly high, because people's lives are literally on the line. So here it is, his 6-point checklist for what he calls high-confidence science. Can you repeat the experiment? Can you measure the results directly? Was it planned out in advance? Does it do its best to avoid bias? And this next one is huge. Does it avoid unstated assumptions? Finally, are the claims it makes reasonable, or are they stretching the data? The more boxes you can check, the more you can trust the result. And this quote really drives the point home. In medicine, you would never accept low-confidence science, right? You expect and you require that the best possible evidence is backing up a procedure. So it kind of begs the question, shouldn't we apply that same level of rigor when we're talking about something as fundamental as our own origins?